Hello everyone, welcome to my channel. Today's topic, design of column. So this is the numerical design of column subjected to a factored load with a given length 3.2 meter. So column, we already know about that it is a generally compression member. So similar to the compression member design, we have to select first from the given loading condition area, and from area we will going to select from steel table I section, and for that all properties of I section will going to check that section for bending, yielding and strength. So in this numerical, factor load already is given, so no need to multiply at 1.5. Next step, calculate the area required. So from IS 800 2007 clause 7.1.2, it is given the area multiplied by the FCD. So here we have to first assume that FCD, and afterward from the selection of the section we will again check that required FCD and calculate it whether it will be greater than or less than as assumed FCD. So for a roll steel section beam, we assume 110 to 180 Newton per mm square. We are taking here 120 Newton per mm square. So area required, we can calculate from this formula. We'll get the 4166 mm square. And after that one, from steel table, we assume or we can select the ISWB 225 about the 33.9 kg per meter its weight, area just greater than the area required, and also write down the all properties of that section. After selecting the section, we have to calculate the classification of that section for flange and web. It is ISMB. So from IS 800 it is given the width of the section divided by the thickness of that flange, which is slightly greater than or less than with respect to the epsilon that we have to calculate. So after calculating this, we can see here the web and flange. The overall section is in under the compact section. After that, we have to calculate the design strength in compression due to the yielding, and it is given in IS 800 2007 clause number 6.2. TDG we have to calculate, this formula is given into the IS code. After that, we have to determine the design bending strength due to the movement, that is MD, and this formula is also given in IS 800 in the clause numbers 8.2.2 page number 54, that is MD equal to beta into ZP into FBD. So here initially we have to assume the beta equal to 1 for compact section, as we already determined the classification of section, that is compact. And after that, ZP we can calculate from the IS 800 2007 annexure H, where ZP is given. ZP is nothing but the plastic moment, plastic modulus of that section. Okay, so to determine the FCD and FBD, we have to first determine the slenderness ratio, that is from this given KL upon RYY, that is R minimum. So assume the end condition that restrain against the translation at both end, but not against the rotation. So from the IS 800, one table is given the effective length, so KL equal to 0.8 L, it is there. So from this we can easily determine the slenderness ratio. So after calculating the slenderness ratio, we can determine from the table number 14 page 57 FBD. With respect to the interpolation, we can determine the FBD. So like this we can draw this table, and from this process we can determine the FCRB. After calculating the FCRB, we can calculate the FBD from the table 13a, page 55, IS 800. Again, with respect to the interpolation, we can determine the FBD. It is also given in the advanced calculator. You can directly calculate this interpolation. After that, we can determine that is moment by again given in IS 800. Again, beta equal to 1 for IS roll section. ZP we can calculate from the annexure H, and FBD we have just calculated. So from this we have given this MD we have calculated. After that we can give the check for the section, that is third one. From this given, again this formula is given in IS 800. If that value is less than 1 or equal to, then that section is safe for the strength. So likewise you can solve this problem